Hello students, welcome to Vyas Edification Kota. In this series of NCERT, we'll be discussing today class 11th exercise 5.2, that is based on the chapter complex numbers and quadratic equation, as you can see behind me. Exercise 5.2 is what we are going to discuss today in this session. Without wasting any further time, let's begin with the first question. Let us take a look at this question here. Find a modulus and arguments of each of the complex numbers in exercise 1, 2, 2. In these two, we are supposed to find the modulus and arguments of the complex numbers. Now, how do we find the modulus and argument? Let's take a look at that first. If we have any complex number z, let us say x plus I y. If we have any complex number z, it's equal to x plus I y. The modulus of z is represented by this symbol mod z. It is read as mod z, and the value is simply equal to under root of x square plus y square. What does modulus of z signify, by the way? Modulus of z signifies when we draw the Argan plane, the modulus of z, any point for any point z, which is x comma x plus I y, the coordinates of this point will be along the real axis. We have to move a distance x, and along the imaginary axis will move a distance y. This is the real axis and this is the imaginary axis. This is the origin over here. So modulus of z basically signifies this distance from the origin to this point P. Modulus of z represents this distance. This is mod of z. As you can clearly observe, this is a 90-degree angle, and x square plus y square under root will give me the length of this hypotenuse over here, which is what we obtain. What else? We are also supposed to find the argument of z. So argument of z is generally denoted by the angle theta, where theta lies in a particular interval. Theta is greater than minus pi, less than equal to pi. This is as per notation we consider this angle, right? Theta could have been anything from here to here. Let us say theta could have been from 0 to 2 pi as well, but then 0 to 2 pi is not something which we consider. We consider from, let us say this is 0, so we start from here minus pi to pi. This is the interval that we consider for theta. These are the principal values of argument of z. Principal values of argument of z lie in this interval. Okay, and the angle made by OP, with positive x-axis, that is my theta. That is my argument of z in general. So when the point lies in the first quadrant, it is very simple to find the argument of z. When the point does not lie in the first quadrant, we have to apply some common sense. Yes. Let's say the point lies in this quadrant over here. So the location of the point is important. Yes, the location of the point is important. If theta lies in this direction, then OP would be actually this, let's say. Okay. In this case, theta would be this. Okay, this is the argument of z. How do we find theta? First, we'll easily find this alpha. And how do we find this alpha? This alpha can be easily found with the help of this right angle triangle over here. Tan alpha would be equal to this perpendicular upon this base. Take the positive values only, and this is perpendicular upon base. You will be able to find alpha very easily. On the basis of that, you will be able to get the value of alpha, and therefore you can find theta. Theta would be simply equal to pi minus alpha. Can you observe that? Yes. Theta would be equal to pi minus alpha, as you can clearly observe over here. In case we have point P lying in this quadrant, so what we'll have is, similarly we'll find alpha in this case. As well. How do we find alpha? This angle would be alpha in that case. With the help of this value and this value, perpendicular and base, we'll find alpha. And the value of theta would be this case. The value of theta, this theta would be actually equal to minus pi plus alpha. The value of this theta would be actually equal to minus pi. This line is minus pi, or this line is pi as well, right? Minus pi, then again you can come over here and say this is 3 pi. But for us it is, like, say you begin from here, you go to here. This is an angle of 180 degree or an angle of pi. You have covered an angle of pi from 0 in the positive direction, therefore you reach pi. In the negative direction, you will reach minus pi, right? So in this case, in this particular quadrant, the value of theta can be written as minus pi plus alpha. For this quadrant over here, the value of alpha, if this is alpha, then you can get theta as well. This is theta. Theta will be equal to actually minus alpha simply in this case. Okay. So in all of these cases, alpha belongs to 0 comma pi by 2. First of all, let us be clear about that. Alpha belongs to 0 comma pi by 2. First we find alpha, and on the basis of that we take a call on the values of argument of z, that is theta, very easily. Alright. So keeping this in mind, let's try to find the argument and modulus for this particular complex number z. Let's try to find this particular complex number z. So we begin with z equal to minus 1 minus I root 3. Okay. Therefore, mod z would be equal to under root of the first term, that is minus 1 square plus minus root 3 square under root. What is this giving me? This will give me under root of 1 plus 3, which is under root of 4, which is equal to 2, simply 2. That's the modulus of z for us in this question. What about the argument of z? Now for argument of z, we know that we have to draw the diagram first and mark the location of this particular point. Let's try to do that. For finding the argument of z, let's try to draw this. There is a point, this point is minus 1 comma minus root 3. Can you observe? Minus 1 comma minus root 3 would be somewhere here, right? This is what we have. This is minus 1. This is minus root 3. Or you can mark the point in this manner over here. This point P is minus 1 comma minus root 3. Let's mark this point. And we are supposed to find the argument of z, which is this angle over here, theta. We are supposed to find this theta. But for finding this theta, first we'll find this alpha over here. Let's try to find this alpha. What is this length? This length is 1 unit and this length is root 3 unit. And what I do is, in the rough, I can find tan alpha very easily. Tan alpha, as you can clearly observe, would be in this right angle triangle over here, perpendicular upon the base, which is root 3 over 1. This is equal to root 3, implying that alpha is simply equal to what? Alpha is simply equal to pi by 3. Now since alpha is pi by 3, therefore theta becomes equal to what? Theta is simply, this is minus pi as well, minus pi plus alpha, which becomes equal to minus pi plus pi by 3, and that gives me minus 2 pi by 3. And yes, this is the argument of this complex number. So we have found the modulus and we have found the argument. Therefore, we can simply say z comma theta, mod z comma theta actually equals, mod z is 2 and theta is minus 2 pi by 3. And yes, this is my final answer for this question over here. Let us take a look at this question. Find the modulus and argument of complex number this. So we have a complex number over here once again, and minus root 3 plus I is this complex number. Let's try to find the modulus and argument. The modulus, as you may recall, is very simple, modulus of z. If this is x plus iy, then modulus of this is x plus iy, right? So modulus of z would be equal to x square plus y square under root. And what will that give me? This will be equal to minus root 3 square, which is 3, y square, which is 1, and under root of 3 plus 1 would be under root of 4, which gives me 2. So modulus of z in this case is 2. For argument of z, what are we supposed to do? We'll draw the diagram, the Argan plane first of all, and mark the point in the Argan plane. So let's draw the Argan plane. This is minus root 3 comma 1. This is the point P. Minus root 3 comma 1 is this particular point. And on joining this and this is origin, this is P. We are supposed to find this theta. This is the argument. This is the argument of z. Minus root 3 plus 1 I. Right, that point is very easy to find, yes. So for finding this angle theta, this argument of z, we'll first find this alpha over here. Okay, for this alpha we need this base and this perpendicular. Okay, what is this base length? This base length is simply equal to root 3 and this is 1. And therefore alpha can be easily found. Alpha is tan alpha can be easily found as perpendicular upon the base. What is the length of perpendicular? Perpendicular is 1 over the base root 3. That gives me alpha equals, if tan alpha is 1 by root 3, what is the value of alpha equal to? Alpha is simply pi by 6. Therefore theta, as you can clearly observe, from here you are moving in this direction. If you reach here, this angle is pi. This line represents pi and you have to subtract alpha from here. This is pi minus alpha. For the second quadrant, you will have pi minus alpha, and therefore that will give me pi minus pi by 6, which is 5 pi by 6. Yes, this is my argument of z. Therefore, mod z comma theta, that ordered pair will become 2 comma 5 pi by 6, and yes, that is my answer for this question. This is the final answer? Yes, this is the final answer for this question. Convert each of the complex numbers given in exercises 3 to 8 in the polar form. Now we are supposed to convert this in the polar form. The polar form is similar to finding the, let us say, modulus and argument. Yes, it is similar to finding the modulus and argument. How do we convert in the polar form? Let's talk about any complex number in general. For any complex number z equal to x plus I y, we can write it in the polar form. The polar form looks like r times cos theta plus I sin theta. This is what it looks like, right? So how do we convert this in this particular form? You can clearly observe that x is simply equal to r cos theta. The real part is equal to the real part and the imaginary part is equal to the imaginary part if this is equal to this. What do x, y and r theta represent? Let me draw the diagram once and explain it for you. For any point P, x comma y in the Argan plane, x plus iy can be represented by this point in the Argan plane. This is the real axis and this is the imaginary axis. Real axis and imaginary axis. Now this point P can also be represented in another way. What we do is, we draw an angle theta first and mark a point at a distance r on this line, right? On this ray at an angle theta, you mark a distance of r and therefore you reach P. So this P can also be represented by this r comma theta. This P can also be represented by this r comma theta. And yes, you can observe from here. What do you observe from here? Can you please observe that? Let's drop this perpendicular and r cos theta. This is r cos theta. This is r sin theta. Okay. This is the base and this is the perpendicular. This is the cos component. This is the sin component. That's what you know, right? So this length is r cos theta, this length is r sin theta, which is also equal to, this length is also equal to this x. This is equal to x and this is equal to y. That's what I've written over there, right? And with the help of this, you can further find the values of x and y. The value of r can be found easily, as you can clearly observe. If we square this and add them together, what you get is r square cos square theta plus r square sin square theta. R square will come out common, cos square theta plus sin square theta is simply 1, which gives me r is equal to under root of x square plus y square. Okay, you could have taken a minus also there, but traditionally, or as you can say, this is the distance and we consider only the positive value over here. So this is r is equal to under root of x square plus y square. This is also known as the modulus of z. Okay. And what else? What about the argument? Argument can also be found from here with the help of, depending upon the location of point P, yes, and we have seen that depending upon the location of point P, we can find the argument very easily. Cos theta and sin theta can be found with the help of x and r. Once we find r, and on the basis of that, we can easily find theta. So keeping this in mind, let us focus on finding this particular, the polar form of this particular complex number 1 minus I. So let Z equals 1 minus I. Okay. Therefore, what will x be equal to? X is equal to r cos theta, y is equal to r sin theta. That is something which we know. Is equal to x plus I y. Let this is equal to x plus I y. Okay. Therefore, x equals 1, y equals minus 1. And we can easily find the value of r, which is equal to under root of x square plus y square. R is simply equal to under root of x square plus y square, which is under root of 1 plus 1, which is under root of 2. So you have found the value of r over here very easily. Okay. Also, we know that x equals r cos theta. Since x equals r cos theta, this implies that cos theta becomes equal to x over r. What is that? 1 by root 2. And y is equal to r sin theta implies sin theta is equal to y over r, which is minus 1 by root 2. You can observe that cos theta is positive, sin theta is negative. Which quadrant are we talking about over here? Can you observe that the quadrant in which the complex number lies can be noted from there directly or from here as well. Cos theta positive and sin theta negative. So you're actually talking about the fourth quadrant over here, right? You're actually talking about the fourth quadrant over here, and the angle alpha can be easily found over here. The angle alpha, or finally you want theta actually. Theta is minus alpha, you know that, right? You remember theta is minus alpha, and tan alpha is simply equal to, can you observe, tan alpha is tuck tuck tuck, this is 1, this is also 1, tan alpha is 1 over 1 implies alpha is pi by 4. Alpha is simply pi by 4, or you can further note that therefore theta is simply minus alpha, which is minus pi by 4. Observe, theta is minus pi by 4, right? So this is the argument of z. You have already found the value of r, that is modulus of z, and therefore z in the polar form can be represented as, therefore z in the polar form equals r times cos theta plus I sin theta, which is root 2 times cos minus pi by 4 plus I sin minus pi by 4. This is what I will be representing the value of z as. Let us take a look at the next one. Convert each of the complex numbers in the polar form. Okay, let's try to convert this in the polar form. So polar form requires us to find the values of r and theta. R can be found easily with the help of, let us say, let z equals minus 1 plus I equal to x plus iy, where x equals minus 1, y equals 1. And we also know that x equals r cos theta. Therefore r cos theta equals minus 1 and r sin theta equals 1. We can find the value of r easily. R equals square root of x square plus y square, which is square root of 1 plus 1, which is square root of 2. You can clearly observe that, right? Therefore, cos theta becomes equal to what? Cos theta is minus 1 upon r, which is minus 1 by root 2. Sin theta becomes equal to 1 over r, which is 1 over root 2, implying that theta lies in which quadrant? Can you identify the quadrant over here? Cos theta is negative, sin theta is positive. Cos theta negative implies, sin theta positive implies that the theta lies in, the point P actually lies in the second quadrant, and therefore theta becomes equal to pi minus alpha, pi minus alpha. And what is alpha? Alpha, as you can clearly observe, would be pi by 4 over here by simply drawing the diagram. By simply drawing the diagram, this is the location of the point P. This here is 1 unit, this here is also 1 unit, and yes, you can find the value of alpha very easily. This alpha, I am talking about this alpha. Tan alpha would be equal to 1, and therefore alpha would be equal to pi by 4, implying theta would be pi minus pi by 4. This gives me the value of theta as 3 pi by 4. That's pretty simple. Yes, that's pretty simple. And therefore, Z in the polar form, the complex number Z in the polar form would be equal to R times cos theta plus I sin theta. R is root 2 cos theta. Theta is 3 pi by 4 plus I sin 3 pi by 4. And yes, that is my answer for this question. Let's take a look at this one. Convert in the polar form, minus 1 minus I. Let's try to convert this in the polar form. What do we have over here is, let Z equals minus 1 minus I, okay, equals x plus Iy. Therefore, x equals minus 1, y equals minus 1. And r cos theta, yes, r cos theta will be equal to minus 1. R sin theta would be equal to minus 1 again. Why is r sin theta? X is r cos theta. On the basis of this, r becomes equal to under root of x. R is equal to under root of x square plus y square. And therefore, you can calculate the value of r, which is minus 1 square plus minus 1 square under root, which is root 2. And cos theta becomes equal to what? Cos theta is minus 1 upon r, which is minus 1 by root 2. Sin theta is again minus 1 by root 2, as you can observe from here. On the basis of this, you can guess that in which quadrant does theta lie. Theta lies in, since cos theta and sin theta both are negative, theta lies in this quadrant, which is the third quadrant. Okay, the point P, as you can clearly observe, the point P is minus 1 comma minus 1, right? So this point P has coordinates minus 1 comma minus 1, and on the basis of this, you can find this alpha easily, yes. Alpha would be equal to pi by 4, and therefore theta is actually equal to minus pi plus this. Theta is this angle, right? This is theta. So therefore theta would be minus pi plus pi by 4, which is minus 3 pi by 4. And yes, this is the argument of this complex number. Therefore, Z equals root 2 times cos theta plus I sin theta. This is cos minus 3 pi by 4 plus I sin minus 3 pi by 4. This is the polar representation. This is the polar form of the given complex number, and yes, that gives me the final answer for this question. That is it? Yes, that is it for this question. Let's talk about this one. Convert in the polar form. Now, this is something different. There's something different about this. It has only real part. It does not have any imaginary part. Okay, that makes things interesting. So let's try to convert this complex number in the polar form. Let Z equals minus 3 plus, can I write it as 0i? Is that okay? Yes. We can write it as 0i. And consider it as x plus iy, where x equals minus 3, y equals 0. And with the help of this, you can easily find the value of r, where r cos theta equals minus 3 and r sin theta equals 0. Okay. So therefore, r will be equal to under root of x square plus y square, which is under root of x square plus y square. Under root of 9 will be simply 3. Why not minus 3? R, in as per notation, we consider the positive value only. So r is plus of this. Okay, that gives us the value of r, and cos theta becomes equal to minus 3 over r, which is minus 1. sine theta becomes equal to 0 over r, which is 0 over 3, which is simply 0. Now sine theta is 0, cos theta is minus 1. Can you guess the value of theta? Very easily, yes. Cos theta minus 1, sine theta 0. Where does it bring us? You should remember, don't ever forget that theta implies the principal values, and the principal values lie in this interval, open minus pi to closed pi. So keeping that in mind, can you guess the value of theta from here? Yes, sine theta equal to 0 would imply theta is multiple of pi, right? Theta could have been minus pi had that been included, but minus pi is not included. Theta can be 0 or pi. And for 0, this gives us 1, but for pi, this gives us a minus 1. Therefore, theta is actually simply pi. This is something which you can observe by plotting the point in the Argan plane as well. There's something which you can observe by plotting the point in the Argan plane like this. This is the Argan plane. Where do you think this point minus 3 plus 0 I lies? That point lies on the negative real axis. This point is minus 3. And yes, this angle would be theta. Theta is simply pi. You can directly observe from there as well. So theta is simply pi, implying z equals, this implies z is equal to what? Z is equal to r cos theta plus I sin theta. Now r is 3. Z equals r times cos theta. Cos theta. Theta is pi. Cos pi plus I sin pi. This is what I'll be getting, and yes, that is my final answer for this question over here. This is my final answer. Yes. Let's talk about this one. Convert in the polar form. So we are supposed to convert in the polar form. Let's try to do it for this one. Let z equals root 3 plus I, which is x plus iy, where x is root 3, y is 1. Can you observe that? Yes. Okay. And x is further equal to r cos theta, which becomes root 3, and y is r sin theta, which is equal to 1. On the basis of this, you can easily find the value of r. Therefore, r equals under root of x square plus y square, and what is that equal to? Under root of x square would be under root of 3 whole square, which is 3, 1 square, which is 1, root of 4, which gives me 2. The value of r is simply 2. Okay. If r is 2, then therefore cos theta becomes equal to what? Cos theta is root 3 over r, which is root 3 by 2, and sin theta is 1 over r, which is 1 by 2. Okay, that is pretty simple. Cos theta is root 3 by 2, sin theta is 1 by 2. It is lying in the first quadrant, and for first quadrant we can easily find the value of theta. Theta becomes equal to, what is theta equal to? Theta is pi by 6. On the basis of these values, you can easily note that theta is simply pi by 6. Therefore, z equals r cos theta plus I sin theta. R times cos theta plus I sin theta, which is the polar form, and which gives me z equals r. What is r? R is root 4, which is 2, and this becomes cos pi by 6 plus I sin pi by 6, which is the required polar form for this given complex number over here. This is the required polar form for that given complex number over here. Right? Let's talk about this one. Convert in the polar form. Now this seems pretty simple. If you can simply draw the diagram, draw the Argan plane and mark this point. This I is actually 0 plus I, which will lie somewhere over here. Point P is 0, 1. And yes, theta would be this angle, which is pi by 2. So I'm solving it directly, am I? Yes, I am just giving you direct approach, direct method. This is 1 and this is theta. Therefore, z will be equal to 1 times cos pi by 2 plus I sin pi by 2. Is that simple? Yes, that's simple. But no. We want to solve it properly. Okay, let's solve it properly. And what do we observe over here is, let z equals 0 plus I, which is equal to x plus I y. Therefore, x becomes equal to 0, y becomes equal to 1, and x is also equal to r cos theta. Therefore, r cos theta is equal to 0, r sin theta is equal to 1. Implying r is equal to under root of x square plus y square, which is under root of 0 plus 1, which is under root of 1. This gives me r equals 1. What happens to the values of theta? So cos theta, can you observe that cos theta would be 0 over r, which is simply 0. Sin theta would be 1 over r, which is simply 1. Now cos theta is 0, sin theta is 1, and theta lies in the interval minus pi to pi. Since theta belongs to minus pi, comma pi, minus pi open and pi closed, implies sin theta equal to 1 implies theta is equal to pi by 2, which is true for cos theta equal to 0 as well. Therefore, the value of theta that you obtain is pi by 2. Z equals r times, which is 1 times cos theta plus I sin theta. That's what you have, cos pi by 2 plus I sin pi by 2, and that is my final answer for this question over here. And with this, we come to the conclusion of this exercise 5.2 of complex numbers and quadratic equation from NCERT Maths class 11th textbook.